Welcome back to the deep dive. Today we're jumping into something maybe you've noticed in the mirror, hair graying, or the science term is Canities.
That's right. And it's not just about looking older. We're here to dig into the actual biology, why our hair loses color.
It seems like there's way more to it than just, genetics and time.
Exactly. Our mission today is understanding how hair color works at a cellular level, what makes it fail, especially under stress, and maybe even if we can turn it back.
Okay, so first off, there's like normal graying, right? I saw this thing called the 50-50-50 rule.
Yeah, that's a general guide. Like 50% of people have about 50% gray hair by the time they hit 50. That's considered, physiological aging, normal.
But then there's the other kind, premature hair graying, PHG. That's different.
Very different. PHG is when graying starts way earlier, before 20 if you're Caucasian, 25 for Asians, 30 for those of African descent.
And the sources we looked at called this a sentinel phenotype, like a warning sign.
Exactly, a canary in the coal mine. Its early onset often points to bigger things going on systemically, things like serious nutrient deficiencies or even autoimmune issues like thyroid disease.
So, okay, seeing gray early isn't just cosmetic. It could be your body saying, hey, look deeper. Let's get into the mechanics then. How does hair keep its color for decades?
It all comes down to melanocyte stem cells, MCSCs for short. Think of them like a reservoir tucked away in a safe spot in the hair follicle called the bulge.
And their job is?
To make new pigment-producing cells every time a new hair grows. Graying kicks in when that reservoir gets depleted, or the cells just stop working right, temporarily or permanently.
Now, this was the part that really surprised me. The chemical damage. It's kind of self-inflicted.
It is, yeah. The very process of making melanin pigment, it's called melanogenesis, actually creates reactive oxygen species, or ROS. Basically, chemical stress.
So making color produces the stuff that harms the color-making machinery.
Precisely. The main culprit seems to be hydrogen peroxide, H2O2. In graying follicles, you find huge amounts of it building up.
Wow. And that buildup is bad because
it kills a key enzyme called tyrosinase. No tyrosinase, no melanin production. Simple as that. And to make matters worse, our natural antioxidant defenses, like an enzyme called catalase that cleans up peroxide, they decline as we age.
So the pollution builds up and the cleanup crew gets weaker.
You got it. It's a vicious cycle.
Okay, let's talk stress. The idea that stress turns hair gray felt like an old wives' tale, but the science actually backs it up now.
It does. And interestingly, it's not necessarily about chronic stress hormones like cortisol. It's more linked to the acute fight-or-flight response system, the sympathetic nervous system.
How does that cause graying?
Well, when you're acutely stressed, your sympathetic nerves release a chemical norepinephrine directly into that little stem cell neighborhood, the niche.
And norepinephrine does what to the stem cells?
It basically sounds a massive alarm. It forces all the MEP-DCs to activate way too early. They multiply, they change form, they leave the safety of the niche.
So it's like a panic-driven evacuation. They leave the bunker before they're needed.
Exactly. And once they differentiate and leave, that pool of stem cells for that follicle is just gone. Permanently depleted in many cases, especially in animal studies.
Oh. Point of no return.
Well, that's what we thought, but here's where it gets interesting. Human studies suggest maybe it's not always irreversible.
Really? How do they figure that out?
By looking really closely at individual hairs. Using high-resolution scanning, they actually found hairs that went gray during stressful periods and then regained their color later.
Whoa.
And crucially, those moments of repigmentation lined up almost perfectly with times the person reported less stress, like after a vacation.
So maybe the first stage isn't cell death, but just cell stress, dysfunction?
That seems to be the idea. An initial phase where the cells are still there, just stress out and not working properly, which might be reversible, before you hit the stage where they're truly gone.
Okay, that changes things. If we can catch it early, what's the new thinking on treatments?
Well, if the cells aren't always gone, maybe the problem later in life or with age-related graying isn't depletion, but immobility. Meaning the MECSCs might still be in the niche, but they get kind of stuck. They lose their ability to move down to where the new hair starts forming, the hair germ, to deliver the pigment. They're present, but paralyzed.
So future treatments might not need to make new stem cells, but just get the existing ones moving again, give them a push.
That's a really promising angle, yes. Focusing on restoring motility, getting those stranded cells back in the game.
So wrapping this up for everyone listening, Gray hair isn't just a passive sign of aging. It's more like a visible logbook, right? Recording the balance between your genetics, that internal oxidative stress, and all the external life stressors you encounter.
Absolutely. And thinking about that potential point of no return, moving from reversible dysfunction to irreversible depletion, it leads to a final thought for you. If the early stages are potentially reversible, what could we track? What lifestyle tweaks or even biological signs could we monitor now to help keep those vital Makey SCs safe and mobile in their niche for as long as humanly possible? Something to think about.